In this video we're going to take another look at GeomInstance in the animation tree. This time we've got our files called character animation 2. We've done things a little bit differently in that we've changed the animation ranges. Now we have a standing animation that lasts from 0 to 10, and then 10 to 20 is the transition from standing to sitting, and then from 20 to 30 is a sitting animation, and then 30 to 40 is the transition back to standing. The reason we do that is because we want to be able to use the animation tree state progress value in order to drive and update and control which behavior happens next. If we had the behavior set how we did before, where standing was just a 0 to 0, then the animation tree state progress always outputs 0, and that's not going to work for us. So what we've done now is we have the standing range set to 0 to 10, and then the transition to sitting would be 10 to 20. Sitting's animation lasts 20 to 30, and transition is to standing is 30 to 40. So what we're going to do, and we're going to not use this node proximity anymore, so we're going to go ahead and actually just disable that for right now. What we're going to do instead, and we'll go ahead and enable the master dynamic. You see we've got just 4 particles here right now. Remember that when they're born, we've assigned them an integer for their animation tree state, which is the sitting state, which is value 1. What we're going to do is we're going to go ahead and create a threshold value that's going to detect when this state progress reaches close to the end. So what we're going to do is we're going to take a threshold, connect that value to the tree state progress, and we're going to do an inside value, or actually we'll just set it to 0.9. So as soon as the value coming in here is 0.9 or greater, it's going to go ahead and activate this output. And what we're going to do with this output is we're going to do a couple things. One of them, we're going to use a memory value here, and this memory we're going to use the threshold to turn this on. We're going to use the tree input, but what we're going to do is we're going to use an expression that's going to detect what the current state is and then figure out which state we want to have happen next. So we're going to go ahead and add an input. We'll call this tree, and then on the add an output called new tree. We'll take our tree state, feed that into here, and then what we'll do is we'll take our new tree state and we're going to go ahead and send it into the memory value and set that tree state. So what this is going to do right now, it says, okay, my tree state progress, I start at 0 when I start playing the behavior, and as soon as I am 90% done roughly, I'm going to go ahead and activate this memory value, which is going to go ahead and do something with this expression and store a new tree state. So what we're going to do is we're going to set up a little expression. It's a really simple one that just says if the tree equals 1, then I want to change it to 0, and otherwise go ahead and just leave it at 1. So if the tree state is 1, we're going to switch to the 0 state. If tree is not equal to 1, then we're going to go ahead and set it to 1. And what this is going to do is we're going to go ahead and actually expose the tree state progress in the debug and show debug information here. And we'll go ahead and scrub forward in time. We'll see our tree state progress is increasing for each particle. Some of them are increasing here. Remember, they have different speeds that we assigned at their my speed value, which is driving their tree master speed. And so what's going to happen is, as soon as some of them reach that threshold value, their tree state is going to change, and they're going to go ahead and stand up. And then once their standing behavior is done, once their tree state progress for the standing, remember, because standing is defined as the 0 to 10. So this tree state is going to go ahead and show the progress through this frame range for every behavior, whichever behavior is current. Okay. So as the standing approaches 90%, or reaches 90% or above, it's going to go ahead and activate this memory value. The memory is going to pull the current tree state. It's going to do this little logic operation and says, okay, if it's this, then make it this, otherwise make it this. And so as they reach the end of their standing behavior, they're going to go ahead and sit back down. And you can see that because their speed is different, remember we assigned the random speed, they're going to go ahead and be playing at different speeds. Let's actually also hide our source guy out of there. Okay. So let's go ahead and take a look. So this is just another way that we can use the HV state progress output, information being sent out from GeomInstance, to detect when a behavior is almost done and use a little bit of logic in the expression operator to control what do we do next. So this is a pretty simple little setup, but it's very powerful for controlling the character's behavior. One of the things that we can also do is we'll go ahead and disable this debug. The A-tree, we've got transition outputs and transition progress, and what these will do is these will output information about the transition that's occurring from our current behavior to our next behavior. Go ahead and turn on debug and you can check those out. Okay, so that's just a pretty quick and simple one there.